YouTube live stream. Okay.
Mhm.
We are excited to have Rainer Hanekamp with us today. It's NG as a meetup. Rainer is a developer, trainer, and a speaker, as well as Google developer expert in Angular. Today, we will be talking about from featured models to micro frontends. Let's give him a warm welcome. You can start.
Okay, thank you. Thank you very much. Then I will first try to share my screen. Let's see if that works. And then we are ready to go. Yeah, looks good, I think. Okay, yeah, also from my side, also welcome. And well, thanks for the opportunity. It's also my first time at NG Asia. And my talk is going to be about evolving architecture. So before I start, maybe a little bit about myself. So Elias already has introduced myself. So Rainer Hanekamp, I'm coming from Austria. I'm part of Angular Architects, and we do workshops, training, consulting, and that stuff. And I usually also try to be very active in the community. So this means I have my own Angular newsletter. This is called NG News. I have my own YouTube channel, and I also try to code as much as possible. So I'm, for example, part of the NGRX team, and I'm also trying to work on other open source projects as well. Good, but we the topic for this talk is architecture. And as you know, the title says evolving architecture, and I think that requires some explanation what it actually is. So the evolving architecture is something where I would say, well, you have different architectural models, but the problem that we always have is that you cannot apply all these models just to any application you want. You want to have something, an architecture that fits to the size of your application. It doesn't kind of make so much sense if, let's say, 50% of my code base is just overhead because my architecture dictates it. I really want to have something which fits for small applications, but also for larger ones. This is one requirement. The second one is we want to have a plan. So if our application grows, we also want to go what the next steps will be in the architecture, what will be the next piece of the puzzle or something else. And as we all know, requirements, they are changing. We cannot be sure if what our customers said today is still valid tomorrow. So we will also want to be able to be a little bit flexible when those kind of requirements change. And this is what I would say, these are the requirements for an evolving architecture. The talk and this architecture that I'm going to explain is coming a lot from my personal experience, but also what we kind of show from in Angular architecture in our workshops as well. I see 5 different stages where the first one has a very strange name. It's called Anarchy. It's a very short stage, or you can even jump ahead and go directly into the split. Then we have the independent features, the grouped features, which we also sometimes call the domains or the scope, and then something for beyond. So even if our application even grows larger and larger, what can we add then as well? The first 2 steps, they are, I would say, fine-grained as the slide says here. So this means that I can show a little bit more by doing live coding. What I mean with these concepts, whereas with 3, 4, and 5, they are more theoretical nature. So there I will stick more to the slides and not do so much in terms of coding. At least that's the plan. And we will start with the first stage. So if we have some kind of an order to write an application, then there is usually always a certain core feature that has to be implemented. And what I usually do is in the very beginning, I want to have something. I want to have a basis. I want to have a foundation. I want to have a minimal prototype that kind of shows that the things that they're kind of working. And that's why I called the first stage really anarchy, but it's very short. Yeah, I just really try to have something very small, straight to the core that shows that this feature can be implemented. It's just a handful elements. I have my app config, I have my app component, another component which is fulfilling, which is implementing that stuff. No routes. This is already too much. And this is how I start. Yo, and before we come to the over engineering versus no plan, because this is always a question which comes up, I would say I'll do a quick warm up and just show you what I actually mean, what the application looks like that I'm going to use here as a demonstration. So the application is already ready. So we have it here. It's just a simple quiz. And you would have to imagine now that the initial requirement was to come up with a website where a quiz is included, which has a lot of features. But in the end, what really counts is there is somewhere a question, there are answers, and I, as an end user, I need to be able to click on the answer, and I need to be told by the system if it's correct, if it's incorrect, or if it has been unanswered. And this, for me, is the core. I don't think about any architecture until at least this minimal implementation is done. And at the moment, it doesn't work. Yep. So I have here a question, just one. I can click on all these answers, but nothing shows up. So I go to my application. And as you can see here, it's a simple Angular application. It doesn't have so many components. It's just, as I said, it's the app component, the app config, and the quiz component, nothing else. So I don't really care about anything. I just try to implement it. And what are we doing here? The quiz component contains the complete quiz, as we see. We have here a very minimalistic template. I am using here already Angular 19, so I'm trying to use the modern stuff, so to say, which means we also see here already the RX resource, because I need to load the data for my quiz from the backend. And with RX resource, we can do this. So it's here this HTTP client where I'm requesting the data. And then I have a computed. Of course, everything is here already done with a signal. So I have here my computed where I say once the data is ready, I want to fetch the first question because this is the one that I want to show. And when I, as a user, then click here on a button on an answer, then the handle answer method is called. And this is now what I would have to implement. So as I said, this is now a kind of a warm-up round that you get used to a little bit to the code that we see here, the way how the application looks like. So handle answer, I'm getting an answer, an ID as a number. So first thing is that I need to get access to the current question. How do I do that? Well, I can say this question is first question. I'm just calling the signal in this case that returns me a question or an undefined, because it could be there could be a probability that the quiz hasn't been loaded yet. So I would then come up here with an if condition where I say if there is no question, then we can already stop. So I'm just going to return here. And if the question is there, then I want to update my status. The status is the signal that we have here. It says you can be correct, you can be incorrect. The question can be answered correct or incorrectly, or it's just unanswered. Yeah. Now I need to update it. So I say, well, yeah, status, I want to set a new value. In order to do this, I need to find out the answer, if it's the correct one or not. So I say here answers find. I'm going to iterate over it. So I say here answer. I say answer ID if that one equals the answer ID which has been passed. And if I find something, and that could now be an undefined, then I say it could be correct. But then I just say, okay, let's just say here we are returning something. And if the answer cannot be found, then we just say it's by default, it is false. And then I say that the thing is correct or it is incorrect, one of these two things. Not sure if the implementation is right. Yep. No, it is right. If it's correct, then we are printing out correct. Yo, and this would now be for me the first step. So if everything now works, I can now click here on maybe a wrong answer. It says then here status, you have answered it incorrectly. And if I click on Oslo, then it says, well, that's really the capital of Norway. So that's why in this case, it's right. And that's it. That's the stage one anarchy, where I don't care about the architecture. I just implement something in a very simple component. And that's it for the beginning. Yeah. And from now on, I have to think a little bit about structure. The question that I want to discuss before is, why do I start with having no plan at all? It kind of looks like I would not have a plan at all, but I want to kind of discuss this a little bit, this over-engineering versus no plan. There are always certain uncertainties when we are writing an application, especially in the beginning. Uncertainties coming from customers because they don't know very likely what they want, or they are very likely going to change the requirements. But also, and there we have to be honest, uncertainties from ourselves. We don't really know how the detailed implementation will look like if we don't have anything. And that's why I said we need to start, we need to have at least something we can talk about. That's the reason. We want to be prepared and we want to have something. End users, as I said, they also kind of like to change their requirements. But in this first stage, it's really us. We want to make sure if we hit any technical obstacles or if anything is there, and we want to know this as soon as possible. There are, of course, always certain certainties. I know that I need an authentication. I know already, hopefully, what kind of UI library I want to use. I know where the backend is located. So for those cases where you already know that this thing is going to happen, you can already implement it. You can already have a plan for it. So that's not really the problem, but we are talking here about the core feature. One thing which is really important, and this also applies to everything that I'm going to say about architecture, there is this kind of thin line between dogmatics and standardization. So I can have certain standards. I can give you an example. We will come to presentational and container components later. But at the time I was a Java developer, I always said every class that I want to write, and not just me, but also my team members, there needs to be an interface that I'm going then to implement. So every class has an interface. Yes, it was very standardized. But the problem was it was also very dogmatic because very often we don't just needed this interface and it was just boilerplate overhead, however you want to call it. The advantage of standardization is always you know exactly how it will look like, but there is also a high probability if you spend too much and if you are too strict in terms of standardization that the things can become very dogmatic. So be careful there. It's really like a trade-off and a very thin line, as I said. And last, before we move on, if we start just by creating a prototype, that doesn't mean that we don't have any plan. You should have an existing specification. You have much, much more requirements about the quiz. So you should think about already a little bit about how the implementation could look like. You want to kind of come up with different strategies, different alternatives. So you want to eliminate those already, where you say, I know already that it will not work like this, so I need to go this way or the other way. But once you have decided for one, then you just start with the prototype. Good. That was the first thing. And then the second stage, which comes afterwards, is then the split. This is now the place where we very early already start to bring in order into our code base. So we start to split up this component, first of all, probably into container and presentational components. This is always something which works. So we can say, well, our container, our component, it has too much code. I want to split it up. And then I can say the visual part, the representational stuff, the template and the CSS goes into a separate component. And the rest, which is very likely the logic, the TypeScript we write, that stays in my component. So the component that I started with, that one becomes now what we call a container component. And the code where we extracted the code to, they are now becoming the presentational components. But it's not just the split between these two component types. What we also have is that you say, well, I have so much logic in my component. There is so much TypeScript in it. Well, then you just take the TypeScript or just take some parts of it and extract them into a service. This is also a possibility. Now this slide here looks like you have two options. In reality, it always goes the wrong way. You will have to split up in both presentational, but also in services. So that's usually the way how it works. And we see here already three different types. Two types for components and another type which is represented by the services. And what we also see here is that we don't just have three types. There is also some kind of relationship between them. And this now means that we can already say, well, there are types included, there are then also relationships included, and maybe also some rules included, who is allowed to access whom. And this is what we see here. So what you usually also want to do when you start with the splits, again, very early, that you want to come up with the basic module types already. What we see here are four types. I usually call that module where I put my container components, I call it feature. I'm not very happy with the name, but this is the term that we see very often. Then my presentational components, they go into the so-called UI module. And the services, they come into data. Why data? Why not logic or something else? Well, usually in an application, the logic, the big part, the major part of the logic lies in the backend. So what our services, our logic in the front end usually do is that they communicate with the backend. It's more like data management. And that's why I like to call this module also data. UI, data, and feature, they will want to refer to the same type. They want to speak the same language. In our case, it's quiz or question. And that's why I always come up with a fourth module type, and that's just called model. Model doesn't contain any Angular specific things. It's just TypeScript interfaces or TypeScript types, just the models themselves. This is what we find there. Once we have it, we have also relationships. So we need to say there are some rules now because feature can access everything. UI can only access model. Data can also access model. But the most important part here is UI cannot access data directly. And the same also goes to data. It always has to go over this container component. So there are these strict rules in place that we want to have verified automatically. And the tool that I'm going to use here is then the sheriff, which can help us here quite well. And I'm going to do this with our existing quiz. So I go back. Maybe I'm just reverting everything, switching to another branch. Asia 2 init, because things have now changed in the meantime. So the quiz has been extended with different functionality. So if I, for example, now go back, we see now that the new quiz contains more than just one question. We also have here a progress bar. So if I click over it, we see that here the progress bar changes. And as a result, the component, this initial component also grew in size. And that's now the perfect time where I start to split up the whole thing. If I already know that it's going to be about the quiz, then I can already start to create a folder. So I would say, yes, I'm going to put all my classes, all my files that I'm going to create into this quiz folder. And then, because I said before that the initial component becomes the container component, and the place for the container component is called the feature, I can also already start to create here the directory, which I'm going to call feature, and I'll move my quiz component into it. So I also know already about the other three module types that I require. So I would say, yeah, there will be a UI. There will then also be a model. And last but not least, we also have our data, where our service will then also be located. So 4 different cornerstones of our quiz feature. So let's start with the UI. As I said, if it comes to the UI, you want to go into the template, and you now need to identify what things can you extract, what basic elements do we have there. And I'd say we just need to look at the screen. We see already the candidates. We would say, well, one question with the status, with the answers, that is a good candidate for an own UI component. A second one might be the progress bar. It doesn't do so much, but yeah, let's just say it's another one because I want to have 2 UI components. And this is what I can do now. So I would then say, okay, I have my UI directory. I say I have my quiz question component, TS. So I start with that one. It's also already, as you see, Angular 19, so I don't need to care about the standalone property anymore. It's now by default true. And I just say I have my selector here, and that would be the quiz question. And it's now code extraction. I'm not going to change anything in the logic. That's a refactoring thing that I'm doing here. So I can go directly to my template of my quiz component. I'm copying the template, which is responsible to render this question card. I cut it out, go back to my quiz question and paste it in there. And now my IDE will tell me what is missing. Yeah, first of all, I should maybe also give it a good name. But my IDE is now saying, well, look, you're missing the question, you're missing the handle answer, and also the status. That is also necessary. And I say, okay, look, I am a UI component. I don't know where the data comes from. I also don't know where the data goes to. So the only thing that I really need in my component, in my TypeScript, is inputs and outputs. And the first input would be the question. So I say, well, I require the question from somewhere, and it's going to be a required input. Don't want to deal with a problem with a potential undefined. And well, now I need to provide the type. So now I need to have access to the types here as well. And that's why I need to do something else before I can continue here. I need to go to my quiz component, and I'll take these two interfaces because these are the models. Remember, I said there needs to be a common language that is spoken within this feature, and that is then located into the model where everyone has access to. So I take it, I go here to model, let's just call it model TS. I paste it in there, and in my quiz component, if everything goes well, my IDE will automatically do here the right import. And I hope that the same then also happens here. No, not really. Yeah, then I have to do it manually. So here I say the question in my UI component wants to have the input. I also want to have the same for the status. So I say, yes, there is then a status, and the status is then just a normal string that I'm going to show. So I say here, this is required. Just give me a string and I'm happy with it. Of course, the status is then a signal. Here, what do I have to do? Well, some minor changes. Add here the brackets like this. And then I have my handle answer, and we know how to do this. This is just an output. This is just an event. So I say here answered. That is a new output, which will emit a number. And then I need to handle this answer here. So I create a method where I say, look, I don't need to have the question from you. It's just important that I provide the ID of the answer because my container component that contains the logic will know to which question this answer belongs to. So that's why I say here, this answered, and I'm just going to emit the ID as it is. And that's it for the UI component. Yeah, so I don't need to do here anything else. I can go straight back to my container component and I say, look, I'm going to use here the question. For every question that I have, I'm going to call it. There will be some things necessary. There will be the question, which I have to pass. It's already there in the template. I also need to provide the status. Yeah, status is also there. Status in this case is a record where the key is the ID of the question and the value then will be the actual message that I want to show. So I say here, the question ID is the one that we have. And then we have the last thing, that's then our event where I say answered. And here I say, well, I have already my handle answer method in my container component. I know the question already, it's the question ID. So the only thing that I require from my child component is the answer ID, and this one is then stored in the event. And I think it's just a question and not the ID. Yeah, I'm closing it, and this was the first step. So it kind of hopefully looks like it's working again. Good, yeah, application is still running. I could not do the other one as well, but looking at the time, I'm just going to skip that. But I would just take this template here and copy it into a second UI component. But I want to do the service because we don't want that the data is empty. So I go to my data directory and I say, yes, we have a quiz service. It's a simple Angular service with provided in root. And this is very easy because our container component now says, okay, the complete logic that we have here, I just go to copy it into the service, the HTTP client, the properties, also the handle answer. I will then just delegate it to it. And in my container component, I have now a very easy time because I just have to say, look, I only need to access the quiz service. So I say here, inject quiz service, the new one. And well, I need to access the resource, the progress, the status, and the handle answer. Very easy. So I say hand read only, quiz resource. Where do I get it from? Well, from the quiz service, just accessing it like this. I also do this for the progress. It's also coming from there. And I have to do the same thing then also to the status like this. Handler answer is also there, of course. Then I say, yeah, that one still has to be a method of my container component. But in the end, here is the answer ID. But in the end, as I said, I'm just going to delegate it. So I see my dear quiz service. Here you have your answer ID. And I'm done with the refactoring. Yeah, so we see that my component, my quiz component, has now shrinked quite a bit. And it kind of is a mediator now. It's not like the one, it's not the central element. I have now really delegated all the things. Mediator, glue code, something like this. It kind of communicates with the service that contains the logic and the data, and it passes it on to the right UI components. This is now the role of my quiz component. And this is also an advantage because now every element, and I see this also from the directories, yes, which kind of elements, what kind of role they have. And someone who sees the code for the first time, they will hopefully understand the code faster than usually because they really understand which component is doing what. So, but this was just the first part. If you remember, I said if you have these types, these module types, so I now just call every subdirectory here a module, then I want to also have some dependency rules. So I don't want that the following thing could happen, that somehow in my quiz question component, in the answer, that it's a UI component. But I don't want that this component just says, look, I want to inject this quiz service on my own. Why do I even have to bother sending in the answer to my parent component? I can answer it on my own. I just go to my quiz service and I say here, handle answer. Yeah, I have the question already. I also have the ID of the answer, and I'm just doing everything on my own. Yeah, so if I write it like this and I save the file, then we see here at the bottom that my compiler doesn't have a problem with it. So it looks like everything is working. And indeed, it is working. So no one kind of prevents me from doing this. But this goes now completely against the design that I usually made up. And here I want to have something which can automatically verify that exactly those things cannot happen. I don't want that my UI component can directly call something from the data. This is forbidden. And as I said, the sheriff could help us here. So the way how it works with the sheriff is that we say, well, in this case, I'm using pm. You can also use npm or yarn, whatever, but you need to have sheriff installed. I say sheriff init, and that one is now generating me a configuration for our file, a simple one. So where do we have it? Here we have the sheriff config TS.
Sorry, but
I need to enable the new mode, then everything is better. But what I can do now with the sheriff is that I can tell him, look, I have 4 modules, UI, feature, model, data, and I have some dependency rules which are assigned to them, and you are now in charge. You make sure that all these modules stick to the rules. So I need to do two things. The first one is I need to define the modules, which is what I do here. The way how we define modules is that we are assigning directories, tags, or you can also see it like roles, but we need to assign them certain values. So I say, well, in my source app, there will be a quiz directory. And I could not say, well, it's the feature subdirectory. This is already a module, but I don't want to repeat myself because I would have to do this now 4 times. So that's why I say, no, there's now a child component, and then we have here the feature. So this is just about shortening the code. And now I say this feature directory that I have, I want to assign it a certain role, a certain tag. And by convention, we usually say type, colon, and then say feature. You can use whatever values you want, but this is a convention, also coming from NX, who have been doing this for many years now. And I'll do the same for the other 3 module types as well. So I say here UI, I say here I have my model, and then here I have my data. That one becomes data, that one becomes model, this one becomes UI. Now I have assigned something. And I can already check if that is actually working. There is a CLI in Sheriff which can show me that. So I just need to say Sheriff list, point it to the entry file, which is main.ts. And if I now execute this command, Sheriff says, yeah, your subfolders, data, feature, model, UI, I have identified them as modules. And you see here also the tags that these directories have. And what I have to do now is that I have to define the rules, the dependency rules, which means we go to tab rules, and there I have to say, well, look, there is a type feature. And when it comes to type feature, it can access whatever it wants as long as it starts with a type. So we only have just one type dimension at the moment, but as long as it is a type, I'm fine with it. Then we have a type data. Type data can only access type model, nothing else. The same is also true for type UI. Also only model. And when it comes to model itself, it cannot access anything. That one is just the last thing without any dependencies. Modules are clear, dependency roles are clear. Well, actually, I can now go back to my UI component, the question component. And if you remember, that one is using the quiz service, which it is not allowed to. And if I do this now, we see now that here this import, this error message comes up telling me you are inside of a type UI module and you're not allowed to access anything from quiz data. Yeah. Of course, the compilation works. TypeScript is not aware of these rules. It's kind of an ESLint process, or in this case, it's the Sheriff process that does this. So whenever someone is pushing something to your repository, you need to make sure that the linter is also executed and that it also fails the build if it goes wrong. Right. As I said in the beginning, I find this is the most important part. It's a little bit more fine-grained architecture, but it's the core of everything. It's the basic elements, the basic roles that you have together with the tool that guarantees you that the dependency rules are kept in place. And everything which comes afterwards is just adding additional abstraction layers on the top. But this is really the most important thing that you remember this. Good. A few words about container and presentational components. They also come under a different name, smart DOM components or the feature and the UI components. Usually I see them as a quick win when I have components which are just too large. In most cases, you can just say, okay, this component is too large, just extract the template to a presentational component, and you will see a significant reduction in the size of this particular class. Again, careful with this dogmatic kind of views. I mentioned this before. We also have very often discussions about this pattern. If you have a component where I say it's not too large, it's just fine, then you don't need to split it into a presentation on a container part, then it's just the component itself. You can see it like it's the container component, but it doesn't have to have a presentational component all the time. When does this happen? Well, if you have, for example, forms, you have a form builder, then your component is just having here the form builder and nothing else, maybe a few files in the template, but it's just, I don't know, 30 lines of code, then I wouldn't see the need to kind of split it into two parts. But as soon as it grows, and remember, this was one of the things that I mentioned in the beginning, you always should have a plan where you want to go to. As soon as it grows, you can then also split out here presentational components. There are different types of presentational components, by the way. The one that we have been using here is a feature-specific presentational component. Usually when we hear UI components, we kind of tend to think about them as they need to be reusable, they need to be generic, they might be part of the shared part, which we don't have yet, but this is a different type. This is just a component which is only meant to kind of reduce or remove the pressure from the container component. It's specific for the container component. It's not meant to be reusable. It's just having something to come up with smaller classes. Shared components are different. They are very generic. They will also not have access to our models. They will not know what the quiz question is. This is then the downside, but they do also exist. This is the presentational container component thing. The other one is about the services. Very often, the question comes up, state management. So as soon as we have something which is called data, the question is very often, oh, do we use state management or not? I don't want to cover state management in this talk. I just want to kind of discuss it here in the slide, and then that should be it. But remember, you have local, you have global state management. The local one only is necessary for a component or for a component tree. The global one is a little bit larger. It's usually a standardization of the services that I have just created. So the quiz service is something where I could say, look, there are some specific standards in my application. I want that every service is done in the same way. Then state management can help you here quite a lot. If we are talking about state management, then you will very often hear, especially coming from the NGRX, from the NGRX store, yeah, I see maybe the benefit of it, but I didn't use it because it was just too much for me. This is coming from developers who used the global store in the past. Modern state management, especially with the NGRX signal store, is not boilerplate, is not too complicated anymore. It doesn't kind of blow up your code base. It's just very small. There are also other state management libraries that you see here on the slides, but the general approach that I have towards state management, I first start with my component. When I see the TypeScript gets too much, I'm going to extract the code into a service. If I see in the service, it's a little bit more than just keeping a signal or keeping the state. I personally immediately go to the signal store because, yeah, as I said, it doesn't come with any boilerplate code. You can, of course, also wait a little bit. You can say, well, if the service kind of hits a threshold, then I need to switch to state management. But in general, honestly speaking, I usually skip the second step if I see that in a component, I have already the need to extract it into a service. I already use the signal store because it's as I said, it doesn't have so much boilerplate. Yeah, and this should it be at least for the service parts. Good. Stage 2, container presentational components, services, all of them managed together via the sheriff. If our application now grows, then we will reach a stage where we will have multiple features. We will not just have a quiz, we will have a booking, we will have holidays, we will have multiple things. And There, we will then also probably, depending on the size of the feature, we will then also kind of try to implement the same module types. What we want to have is that these features should stay independent from each other. That is very important because otherwise this kind of silo does not work anymore. What we also have, as soon as you have two features, that you will find yourself reusing certain services, certain UI components. As soon as you do this, they are already becoming a candidate for shared components. Yeah, so I always try to don't over engineer. I usually wait for the code to show me in which direction I need to go. And this also applies to when I need to identify what should be shared and what should not be shared. As soon as I see that some element is used by two different features, it's already getting into the shared module. What is important to add here as well? As I said before, features or these feature groups, they are now an additional layer on top of this kind of four core element types that we have. They should be independent, but it doesn't work all the time. There will be shared elements, yes, and you will also have the need sometimes for an API for dependencies, inter-feature dependencies. It could be the case that, for example, the booking requires certain data from the quiz, or maybe the other way around. You can't avoid it. This will just happen. But you should try to minimize those occasions where you need to be able to access that. So 100% independence is almost impossible. The question is again, how do we do this? And here, I want to do a quick jump. I don't want to do the implementation, but I just want to switch to the solution branch and just show it how it's done. Let's see if I manage to remove everything. Yeah, wonderful. We are already at 3 features solution. Right. Here we have it. So we see here our old quiz feature as untouched. And we see that now an additional one has been added, the booking one. The booking one is now a feature which is very small. You see, it doesn't do anything. So I didn't really see the need to come up with presentational components, services. But what I did instead is that I said, well, if it's just one component, then I put it into the feature directory so that my Sheriff configuration can be applied. Next, to this booking and quiz. We also see here user service, and that's now part of shared. So this is this other part which is running next to our feature components or feature modules, sorry. And we also have here the booking service, booking info service. And this service, in this case, is an API. So the booking feature says, I'm going to provide this booking info service, which exposes a limited set of data that I have to other services who require it. And in my case, it's the quiz component. So the quiz component says, I need to be able to use the booking info service. Again, careful. Don't do this all the time. You are doing this modularization, this dependency rules to be decoupled as much as possible. So be really careful when you do such things like allowing another feature access to another one. Sometimes, as I said, it is necessary. The question is, do we have to change here anything? In terms of structure, no, not really. It's just another directory which we have. The same applies to shared. For Sheriff, there are some tiny changes necessary. I want to quickly show them. So if I go into my Sheriff config, we see first of all, you need to mark the shared as a special one because it doesn't have the subfolders of feature UI and so on. And then we can use here placeholders. So we say, in this case, everything, every subdirectory in source app, which is not shared because that one has already been handled with. So in this case, it's just the quiz and the booking. I now say this is a domain. You can also say scope or whatever, but in my kind of perspective, it's a domain. It's an additional dimension, which I didn't have before. Yeah, before we only had types. But now we also need to assign those types to a certain domain. Why do I have to do this? Because I don't want that a feature type like the quiz component, can now access something from booking which is of type UI. I don't want to allow this. And this is why I require this second dimension coming with domain. And for obvious reasons, it also blows up my configuration for Sheriff, because now it's not just about the typing rules. I also have to care now about the domain rules. And you see here the way how I handle it. So every module in quiz, for example, has now assigned domain quiz. Every module in booking has also assigned the domain booking. This is why I'm using here placeholders. And I say in the dependency rules, as long as the modules are coming from the same domain or coming from shared, from the domain's perspective, I'm going to allow access. I don't know what the type dimension will do. This is done another rule, but from the domain, as long as it has the same name, I'm going to allow it. And then we have a special case for the API where I say yes, but there is one exception to the rule. There is this API of domain booking, and I'm going to allow only the domain quiz to access the domain booking API. I don't know how often I said it, how often I said it already by now that you should try to avoid it, but this is the way how to do it if you ever need to use an API. Good. Right. Yo, and then we move on. So if we would now say, yeah, wonderful, we have now multiple features in our application. Within every feature, we have these module types. Then you will very soon hit the next obstacle. And for example, let's say, well, I'm in holidays. I have now 2 or 3 features, but all of a sudden, these 3 features, they in a way require access to the same services, to the same data. What should we do then? Well, there is this approach that we see here on the left side that we say, yeah, quiz, brochure, and shop. They are 3 different distinct feature modules, feature folders that could work. They all have a dependency to a single data and to a single UI library. Yeah, kind of works. In reality, though, the data will become very large because the data will have to contain all the data for all the features, and it will scale with the features. So the more features I add, the bigger, the larger this data becomes. So I have to think about this as well. One possible approach, which will not work, by the way, are independent sub-features. So you say, well, you put just everything into holidays and they don't really have anything to do with each other. Quiz has its own data, brochure has its own data, shop has its own data. Yeah, but then you don't even have to put them into holidays, then they are just domains on their own. But as I said, this will not work because they will require access to the same set of data. The best solution in this case is if you have multiple features and you identify a certain core structure. What do I mean by this? If you have a quiz, then usually the quiz is always bound, is always associated to a holiday because we are in the domain holiday. So every quiz, as we have seen in our example, it is assigned to Norway, for example. So this holidays entities is something which is now part of the core. And the quiz comes with its additional entities that are related to the core. The same is true for the shop. I might have a shop where I'm selling certain things for a particular holiday. It's the same thing again. The shop will bring its own entities. They could be called product, I don't know. But the product will always be assigned to a certain holiday. Yeah. So the core itself doesn't expose any components because it's not a feature on its own, but it is a shared set of state management, of services, of reusable UI components, specific domain UI components that my features will depend on. And this is something where we are already talking about a very larger application code base. And it is very likely in these cases that when it comes to, again, the sheriff configuration, that you have to add another dimension, a third dimension. Next to domain and next to type, we then also have a third one, which defines quiz is a subfeature or a subdomain, shop is another subdomain. It's kind of like this, we call it matrushka, where you just open it and different layers, the more you go downwards. But this is exactly what you have with very large code bases. And the core really kind of proved itself. I also have it here, for example, in the, I can also show it very quickly in our code base. So there is this feature groups. Let me quickly, here we have it. So here you see this is already much, much more code. Here we have our quiz, but next to the quiz, we also have this brochure. We also have an overview. These are features on their own next to subquiz, but what they all have in common, they have one common term, which they all have the same understanding for, which is the holiday. They all have a common state management. In this case, it's the holiday store. And as I said before, managing the dependency roles becomes now even harder because now we have 3 dimensions instead of 2. So if I go here to sheriff, you see it here already, subdomain. So this is this third dimension that I had to introduce in order to let the brochure overview and quiz, let them have access to my core services, but I still want to disallow that brochure can access, for example, the quiz or the other way around. This is why I need this third kind of layer. Yeah. So you see, it's becoming more complicated with the size of our application. And then we have the last thing, scaling up, scaling out. So if our application would now still continue to grow, we would add more and more things, everything becomes more and more complicated. And let's start maybe with microfrontends. And with the growth, with the size of the application, you also have an increase in the amount of developers who are working with the application. Then your main problem is the coordination between these people. And if this is the problem, then it's actually very easy. Then you just go with microfrontends. This means that these teams, relatively speaking, can work in isolation. Every team kind of has its own part of this application. And during the runtime, they are just being merged together. We can't share there anything. This because we want to have separated teams, so we cannot allow to share anything. I mean, there are, of course, always exceptions. There will be some certain central services, platform services, which will be provided, like authentication and that stuff. That needs to be shared. But in general, something like I have an API from one feature to another. No. Then you go to the backend and fetch it from there. So you fetch in the data, for example, twice. What you have to kind of consider if you're going to use micro frontends is that it's becoming technically very challenging. Don't want to go into the details, but it's not easy. It's also not officially supported by Angular, so you have to do some pioneering work. There are libraries, frameworks from us, but also from NX who can help you with that. But usually if you go the micro frontends path, you have to invest some knowledge, some time on your own. And usually what you always have is what I always say, you require a special task force team who knows about the setup, the structure, and know how to deal with the issues. The other one, the more maybe interesting one, because we don't hear about it so often, and I'm not even sure if I would call it hexagonal architecture, it's just borrowing ideas from it, is if our application grows, but I still manage to keep the team as it is, so I don't need additional developers. Project can take many years, and I would say, well, I still want that my team can still manage and extend it. What you want to do then is that you want to kind of reduce the complexity of your projects. So you don't want that everyone needs to know about all the libraries that we are using and all this stuff. So you want to make it as easy as possible. And there this, what I meant before with borrowing an idea from the hexagon architecture, is the way how they fix this problem. We have a domain. Inside of this domain, we have the logic. This could be a component, can also be state management. It doesn't matter. But the point is, you have another dependency to somewhere else. And this is what I said before. I want to be able to reduce the amount of dependencies. If I look at the code which is inside of the domain, I don't want to know what kind of dependencies are used there, what libraries are used there. I just want to focus on that thing which is running in the domain only. And the hexagonal architecture, and it's also very often called ports and adapters, what they are doing is that they say, look, you can, as a domain, you don't need to know about the dependencies. You just define the feature, the function that you want, and as you want it. You don't need to kind of consider any constraints from a certain library. You just define an interface. In our case, it's an abstract class where you say exactly what kind of API it should provide. And then somebody else, but not you in the domain, is creating an adapter. That adapter will know what you want as a domain. It will also know what dependency is required in order to get this right, to get this running, and it will provide you with the particular service that you want. Sounds very complicated. I have an example for it, but the basic thought process about it is really that I, for example, as a component can say, I don't want to know what NGRX is or what, I don't know what web workers are or whatever libraries you are using. I just want to have a service where I say, can I do this or can I do this? This is what I want. And the way how it could look like. Let me quickly show this hexagonal architecture, is that we have now again our quiz component. And the quiz component now says, look, I have here a demand for a user info. So I want to know in my quiz if the user has booked the certain holiday which I'm currently showing in my quiz, because I want to show a message if it hasn't been booked yet. I don't want to have any dependency to any booking module. I don't even know that it does exist. I only say what I need. So I say I want to have this user info which has the user booked, whatever. Now, the booking has this kind of service, but both booking and quiz, they don't know about it. And instead, we are now introducing a third element, which is the adapter. You can create an own module if you want, but I have done it just right in the application, in the app config here. And what the app config is doing, that it says, well, let me quickly jump to the default user info. It says the default user info is implementing the user info that my domain, that my quiz component requires. I'm going to implement it. But I don't need to re-implement it because it has already been done. I just need to connect the parts together. So this file here has, let me quickly go back, has now a dependency to the actual user info service and to the domain. And both don't need to know about each other. It also can do a little bit more. It also has here, for example, the user service. So it brings in even a second dependency. It delegates the logic to those dependencies and then just returns whatever the booking info here is kind of doing. And if I would now have here a visual graph or something like this, I would see that I have now reached a state where quiz booking can be in full isolation. But as always, I need to add an addition layer on top, which is then mediating between these two. But if you have this, you can really reduce the complexity because you don't have so many dependencies. You will have an additional layer as always. It's another indirection, but sometimes that's maybe better than the other way around. And by saying that, I have already reached exactly 1 hour. I would be finished with my talk so far. And if there are any questions or so, I would now be very happy to answer them.
Yes, there is a question in the chat group. Can you check
Yes.
it?
Yep.
It's from YouTube, our subscribers.
Okay. From Thomas
Yeah.
Prickel, won't extracting the questions into their own component affect the DOM? The app question will now be where the original diff was, so you might encounter some problems with the style selectors. Yeah, I mean, if you have UI, if you have presentational components, they are responsible for their own styles. So inside of the component, um, they have their own stylings when it comes to the layout. So I think maybe that's the problem here that Thomas is referring to, that now the CSS classes or the CSS rules become a little bit destroyed because we have additional DOMs. Yeah, then you have to fix that. But this is something you have to be aware of. The other question, it would be cool if the modules could auto-discover the path and just recognize any folder in the given path, give it feature asterisk as key. Yes. So I think maybe this question has been asked before we reached the feature groups, because in the beginning I had hard-coded quiz inside of the path, and in the feature groups I replaced the static value with a placeholder, which in this case could be seen as this asterisk.
Yes, thank you. Thank you for all joining today and at the meetups. A big thanks to Rainer Honeycomb
Thanks.
for his clear and insightful talk. We hope you found it helpful and inspiring. Let's keep learning and build amazing things together. See you next meetup. Thank you very much.
Goodbye.
Bye.
Thank you.